All right, hello, sixth graders, and welcome to lesson 2, where today we'll be discussing mainly outliers. All right, so we're going to be taking a lot what we learned last section and just adding in one thing. And today we're going to add in what's called an outlier. All right, an outlier is a value in a data set, that is very different from the other values. Okay, so basically what an outlier does is it throws off some of your data, so it makes it look a little bit skewed. So we want to be good at looking at our data and seeing if we do have an outlier, how will that affect our data? All right, let's take a look at the first example, and you'll notice that we're doing a lot of the same as what we did last section. It says find the mean, median, and mode of the data in the table. Okay, so here's our different games for the football games that we won. In 98, we won 11. 99, we won 5. In 2000, we won 7, and so on and so forth. Let's line up our data here, and I'll line them up in order. So I've got 2 5s, I've got 2 7s, and I've got 11. Least to greatest, here's my numbers. All right, remember the mean is adding up your numbers and dividing by how many they are. So 5 and 5 is 10, plus 14 would be 24, plus 11, 24 plus 11, 35. If I divide that by how many numbers there are 1, 2, 3, 4, 5 numbers, that would give me a total of 7. So my mean or my average is 7. The modes, the numbers that occur the most, well, 5 occurs twice, and so does 7, so I'll include both of those. And then the median, right, you can, to find the middle, subtract 1 from the bottom and 1 from the top, and 1 from the bottom and 1 from the top, and my middle number is 7. Okay. It says EMS also won 13 games in 97 and 8 games in 96. Add this data to the table to find the mean, median, and mode. All right, so if I were to add 13 and 8 to that, 35 plus 13 would give me 48, plus 8 for the 8 games in 96, bring me to a grand total of 56. Divided by my total number of games now would be 7. The original 5 plus these 2 games, it's 7. 56 divided by 7 is 8. So my mean or my average now would be 8. My modes would be unchanged. 5 and 7 both are still the most common, or they occur the most. And then the median, how would my median change? Well, let's line them up again. So least to greatest, 5, 5, 7, 7. Next would come 8, then 11, and then 13. 1, 2, 3, 4, 5, 6, 7 games. Yep, that's right. All right, finding my median, cross off one of the low and one of the high, and work my way towards the middle. And my median is 7. All right. So looking at the data here, from A to B, it says the blank increased by 1. Well, the mean increased by 1, so my average increased by 1. The blank remained the same. The modes remained the same. And the blank also remained the same. The median also remained the same. Okay, so you'll notice our mean or our average changed. The average went up because we have what's kind of an outlier. 13 games won in 97. That's a lot compared to the median of my data, which is 7, and the average of my data, which was 7. We were averaging 7 wins, and we almost doubled that this year. So that's why our average or our mean increased, because we had what we considered an outlier, a number that was a lot bigger or a lot smaller than the average of all the other data. All right, go ahead and flip the page now. In example 2, it says Miss Gray is 25 years old. She took a class with students who were 55, 52, 59, 61, 63, and 58. Find the median, and mode with and without Mrs. Gray's age, Miss Gray's age. All right, so what we will do here is first find the mean, median, mode with her age. So we've got 55. Actually, I'm going to line it up in order right now. 25, 52 would be the next. 55 is next oldest. 58, 59, 61, and 63. Let's just double check. I have 1, 2, 3, 4, 5, 6, 7 different ages. 1, 2, 3, 4, 5, 6, 7 different ages. Perfect. So I'll add up my numbers here. So 25 plus 52 plus 55 plus 58 plus 59 plus 61 plus 63 would give me 373 divided by, there were 7 ages there. And notice it says about, that squiggly equals means about. So I'll just round. Gives me 53.3. And it's okay to use a calculator here, because we're just kind of punching numbers in and seeing what we come up with. We're not really working on adding, we're working on mean, median, mode, and such, okay? So our average age is 53.3. Our mode, the number that occurs most, well, there's no mode there. Each number occurs once. And the median then, let's find our median, crossing out 1 from the high, 1 from the low, and I come up with 58. All right, let's compare that to the data without Miss Gray's age. So now we're going to not add in her age, so we're just going to use the people that she took the class with. 55, 58, 59, 61, 63. So if I take that 373 and I subtract her age of 25, I have a total of 348 divided by 1, 2, 3, 4, 5, 6 ages would give me a total of, now the average is actually 58 years old without her age in there. There still is no mode. There's no number that occurs more than once. And the median, let's cross out here, highs and lows. And I'm left with 58 and 59. So what would be in between 58 and 59? That'd be 58.5. Okay. So when you add her age, the mean decreases by about 4.7. And what stays the same? Well, the mode stays the same. And the median decreases by 0.5 from 58.5 to 58. So what's most affected by the outlier? Well, the mean or the average is, the mean is 58 without, and with it's 53.3. It's 4.7 difference is most affected by the outlier. Okay, the median is closer to most of the students' ages. So we would say that the median is the most accurate representation of this data. When you throw in Miss Gray's age in there, when you throw in that outlier into the data, it really skews things because her age is way younger. She's like half the age of everybody else. So we would use the median then to be the most accurate set of data in this case. Right. Last example here, example 3 says the Yorks found 8 pairs of skates with the following prices. What are the mean, median, mode of the data? And what statistic best describes? Okay, so the mean, adding up all our numbers, again, feel free to use a calculator here. 35 plus 42 plus 75 plus 40 plus 47 plus 34 plus 45 plus 40 gives me a total of, oops, let me get my pen out here. When I add up these numbers, I get 358, and divided by the total number of skates there, which is 8, should come up with about $44.75 for the average cost of the skates. Modes, I have 40 repeating itself twice. So that occurs the most. The median, let's line up my data here. So 34 is my smallest, and 35, 240s. And let's just cross off and see what I'm left with here. 42, 45, 47, and 75. So 1, 2, 3, 4, 5, 6, 7, 8 pair of skates. Good. Then I'll work my way towards the middle, canceling out one in the bottom and one in the top. And I'm left with 40 and 42. What's in between those? What's in the middle? That would be 41. Okay. And again, these labels are dollars. Okay. So the what sets of these data points is closest to what most pair of skates cost? Well, if you took all of these numbers and looked at what is the closest number that you could get to for if you were to say you took all the skates, which one best represents the prices? And I would say it would be the median, because the mean or the average is a little bit higher than the rest of the data. And again, notice that's because of the outlier of $75. There's one really expensive pair of skates, and that skews our data. That makes our average go, $3 or $4 higher than our other sets of data. Most of the skates cost about $41. They're all really close to that. So the mean is higher than most of the prices because of the $75 skates. All right, that wraps up the examples today. Please pause the video now and try the 3 check it out problems on your own. And then once you've done them, come back to see if you got the right answer. All right. In hopes of not making this video too long, I'm just going to give you the answers here. And if you have questions about them, please come ask. If you didn't quite get them right, don't be afraid to ask a friend or something. Mean for the first one is 8. Mode is 6. And the median is also 6. For the second one, first we'll do with Miss Pink's age. So the mean is 29. There's no mode. And the median is 25. And then without, I'm going to put W/O, the mean is 24.5. You can see it drastically changes. Still no mode. And the median drops a little bit to 24.5. And finishing with the last one, I come up with mean is 18.25. The mode is $15, and the median is $15.50. And it says which statistic best describes it. Well, the median is the best representation of the prices because our average or our mean is higher because of this $39 outlier. All right, once again, questions, please come see me. Biggest idea from this section is outliers and how they can skew your data. I will see you guys next time.